There you go. All right. So this is the first problem that you have on this worksheet, right?
Yes, sir.
And it's a pretty good problem. You notice you have an absolute value within an absolute value, right?
Yes, sir.
All right. So let's look at this first one real quick. So let me do a quick snippet of that. Um, so if you back up real quick, you remember that the absolute value normally is the distance. If we're solving something like x, absolute value equal to 5, we're talking about the distance from the origin. So we have 0 here going to positive 5 and negative 5, right?
Yes, sir.
My result going to be negative 5 and x equal to positive 5. Now, the beautiful thing about this problem is it's an absolute value within an absolute value. So we use the same principle here, but we're going to use it twice. So we're going to get x minus 3, and we have the absolute value minus 5. Now, for the first absolute value, this is going to be equal to positive 1, and that's going to be x minus 3 minus 5 equal to negative 1, applying this principle, right?
Yes, sir.
All right, so with that being the case, we're going to go again one more time. The first one right here, going to be x minus 3, absolute value. Bring this over. This is going to be giving me negative 5, plus that's going to be 6. So I'm going to get x minus 3 equal to negative 6. X minus 3 equal to positive 6.
Yes, sir.
That's good. So this one, I'm going to suggest that x going to be equal to, we have negative 6, and we're going to be adding 3 to both sides. Adding 3, what I'm going to get, that's negative 3, right?
Yes, sir.
All right. Adding 3 to this one right here, going to give me also 9. So here, x going to be equal to 9.
Yes, sir.
That's pretty good. All right, so notice there, which is pretty awesome about this problem. Again, it's an absolute value within an absolute value. So this is just 2 solutions that we have here, but bear in mind that we have 2 more solutions to take into consideration, right?
Yes, sir.
All right, so let's look at that real quick. So with that being the case, with the absolute value right there, we're going to take this piece now, right?
Yes, sir.
All right, so for that piece, we're going to have x minus 3. We have the absolute value, minus 5. This is going to be equal to negative 1. But if I add 5 to both sides, let me just rewrite it here. Add 5 to both sides, we're going to get negative 1 plus 5. So that's going to be x minus 3, absolute value. That's going to give me 4, right?
Yes, sir.
Split the absolute value again. I'm going to have x minus 3 equal to negative 4. Let me just erase that real quick. And that's going to be x minus 3 equal to positive 4, right?
Yes, sir.
So this one going to implies if I add 3 to both sides, I'm going to get what?
7.
No.
I got the wrong one. Oh, I'm sorry. Negative 1.
Excellent. So I'm going to have x equal to negative 1. Okay. And if I add 3 right here, just like what you just said, x is going to be equal to 7, right? So our answer here going to be x equal to negative 1, x equal to 7, x equal to negative 3, x equal to 9.
Yes, sir.
Now, I want you to make a note of these answers because we're going to use these answers to actually help us to do the next problem, right?
All right.
All right. So just make a note of these. Do you need to copy this?
Yes, sir. Just give me 1 second.
Okay, then. So let me pause while you're copying. Okay. Okay. So with this, looking at this one now, let's do a quick snippet of this. So 1B. So one of the important things is that because we're dealing with the real number line, we need the values to be positive. So we know that the square root of anything negative right here, if we have negative 1, it's going to give me I, right?
Yes, sir.
And because of this fact, we need to solve then the absolute value of the absolute value, x minus 3, minus 5, absolute value minus 1, greater than or equal to 0, because that's what we need. Now, one thing I want to ask you real quick. why do I use equal to 0 and not just greater than 0?
Can you square root 0 and it will still give you 0, or is that not the right answer?
That's exactly the answer.
Okay.
Because you can square root 0. So very importantly, this is greater than or equal to 0. Now something very important. If I suppose I want to be difficult and I put that over 1, it would not be equal to 0 now, because if it's equal to 0, it would be undefined, right?
Yes, sir.
Okay, and I just want to hit that point because that comes up a lot in calculus when you're dealing with situations like that. All right, so let's jump into the solution now. So if we have the absolute value of x greater than or equal to a number, let's say 2, we know this is the distance that is bigger than 2, right?
Yes, sir.
So 2, -2, we need a distance bigger than -2, so it's going to be right here, going this way, right here, going this way. And that would be the distance bigger than 2 from 0, right?
Yes, sir.
All right. I want this to be absolutely clear to you. Now, once we're making the solution for this, it's going to be OR. So we're going to actually have negative infinity, right? Because it's greater than or equal to, we're going to have a square bracket. I call these brackets, okay? Normally the books say parentheses and they say bracket, but I call all of them bracket. Let's call this one curve, call this one square, okay?
Right.
All right. So with that being the case, then it's going to be at -2 or 2 going to positive infinity, right?
Yes, sir.
All right, so let's apply all of that now. It's a simpler problem. Let's apply it now to this bigger problem. So for this bigger problem, we're going to do that. The first thing we're going to have is we need to split this out of the sign right here. So we're going to have x minus 3 absolute value minus 5 minus greater than or equal to, let me just keep it here just to be consistent, greater than or equal to 1, right?
Yes, sir.
All right. So what I'm going to have now, so if I'm going to treat this like what I did before with x, I'm going to have x minus 3, the absolute value, minus 5, greater than or equal to positive 1, right?
Yes, sir.
And I'm going to have, let me just erase this because I'm running low on space. And then I'm going to have x minus 3 absolute value minus 5 going to be less than or equal to -1.
Yes, sir.
Make sense?
I know that you're supposed to change it to a less than or equal to, and then you get 1, because you explain to me like why the process, like why it's
all right. So let's do a simple example. So that's why I was trying to do the example before, but this one is massive, and that's why it looks a little bit more complex. But it's still the same problem. If I look at a simpler version of this problem, the absolute value of x greater than or equal to 2, right?
Yes, sir.
All right. So this here is a distance where it's bigger than 2, right?
Oh, okay, never mind. I got what you were saying with the last example now.
You got it?
Yes, sir.
So all of this now becomes my x. Do you realize that?
Say that one more time, you kind of cut out.
All of this becomes my x.
Yes, sir.
Okay, so it's going to be greater than 1 and less than -1 because this is a distance that is bigger than 1. Make sense?
Yes, sir.
All right, let's keep it going. So with that being the situation now, let's look at this problem. So we have 2 pieces and we have to solve them separately. So let's do the first piece. So we're going to have x minus 3. Let me put back the absolute value, greater than or equal to, bring that over, it's 4. So with this being the case, notice now I'm going to have x minus 3 greater than or equal to 4, right?
Wouldn't that be 6?
For
this one, since you're adding 5 over to...
Oh, sorry, my apologies. It's supposed to be 6, right?
Yes, sir, you're good.
Hold on a minute. You have x minus 3, absolute value minus 5, greater than or equal to 1. Then we have x minus 3, absolute value minus 5, greater than or equal to 1. So this is going to be 6 indeed, right?
Yes, sir.
Okay. So with that being the case, let me just double check. We have x minus 3, x minus 5, minus 1, greater than or equal to 0. X minus 3, the absolute value minus 5, absolute value greater than or equal to 1. X minus 3, absolute value minus 5, greater than or equal to 1. All right? So this now going to be greater than 1. So with this greater than 1, we're going to add 5 to both sides. We're going to get 6, right?
Yes, sir.
Okay, good, good. All right. So with that being the case now, correction, we have the absolute value greater than or equal to, it's going to be greater than or equal to 6, right?
Yes, sir.
And it's going to be x minus 3 also going to be less than or equal to negative 6. That's good?
Yes, sir.
All right. So with that being the case, I'm going to now add 3 to both sides. So I'm going to get x greater than or equal to 9, right?
Yes, sir.
And then I'm going to get x less than or equal to, bring this to both sides, I'm going to have it less than or equal to negative 3, right?
Yes, sir.
All right. Let's do the next piece now real quick. So this is just this first piece right here, right?
Yes, sir.
All right. So let me use a different color to differentiate, black. All right. So we have x minus 3 absolute value minus 5 less than or equal to 1. So we're going to have x minus 3 absolute value less than or equal to, if we add 5 to both sides, what we're going to get?
4.
4. Good. All right. So probably my brain was working backwards. Because notice I wrote 4 right there.
Yeah.
All right. So with that being the case, yeah, because I know the answers from above, that's why.
Yes, sir.
Okay. So we have the absolute value of x minus 3 less than or equal to 4. Now, again, this one is a little bit different. We want the distance where it's less than 4. Now, again, if I have the absolute value of x less than or equal to 2, using the same one, is now the distance where it is less than 2. So it's going to be between negative 2 and 2, right?
Yes, sir.
So that's going to be my answer because I know that's the distance where it's less than 2 from the origin. So with that being the case, this then going to be x between 2 and x between negative 2. So we do the same thing right here. We're going to have x minus 3 less than or equal to 4, less than or equal to negative 4, right?
Yes, sir.
Follow?
Wait. I mean, I get it. Is it? Hold on. You're putting it in between because it's the less than symbol and not less than or equal to symbol, not the greater than or equal to.
Perfect. So
okay.
So notice my diagram up here.
Yeah.
We have negative 2 to 2. So this is the distance where it's less than 2. So if I want a distance now where it's greater than 2, remember it was over here, right?
Yes, sir.
Now it's inside here because this is the distance where it is less than 2 starting from 0, the origin. So
yes,
from
sir.
0 to 2, 0 to 2. Notice that it goes both ways, right?
Yes, sir.
So x then going to be between 2 and negative 2. All right. So with that being the case, now what I do now, I'm going to operate on all 3 pieces. So I'm going to add 3 to both sides, add 3, right?
Yes, sir.
Negative 4 plus 3 is?
Negative 1.
Negative 1. Less than or equal to, add 3 to this, we're going to get just x, right?
Yes, sir.
Less than or equal to, add 4 plus 3, that's going to be 7, right?
Yes, sir.
All right. So the easiest way now, we have to now represent all of the specific domains that are given for this specific problem. So what we're going to do, the best thing I always suggest is that draw a number line and put everything on the number line and see where everything falls, right?
Yes, sir.
So we had negative 3. And so it's going to have a solid dot at negative 3, and we're going this way, right?
Yes, sir.
We're at 9, so I'm going to put 9 right here. We're going to have a solid dot at 9, and we're going this way, right?
Yes, sir.
All right, we're at negative 1, going to be somewhere here. Solid dot at negative 1, and that's going to be going to about 7, right?
Yes, sir.
So combine now my domain, that they want going to be from negative infinity to square bracket at 3. You see that?
Yes, sir.
Or square bracket at negative 1, square bracket at 7. See that?
Yes, sir.
All right. And then this is going to be square bracket at 9, going to positive infinity. Just let me make a disclaimer here. I call all of these brackets for conversation purposes, okay? But most of the American textbook here say parentheses. So I just want to make that disclaimer right here because I'm recording the video, okay?
Yes, sir.
Okay, so is this one good?
Yes, sir.
All right. Now I want to do a quick demo.
I'm sorry. Is there supposed to be an or in between 7, the bracket?
Yes. It's or. Now it can be or this symbol. The symbol means union, right?
Yes, sir.
All right. Now I want to do a quick demo to just show you what the graph look like. And this is a quick way for you to verify if the answer make any form of sense, right?
Gotcha.
So that is your graph, right?
Yes, sir.
All right. You need it to be greater than or equal to 0. Greater than or equal to 0 going to be right here above the x-axis, right?
Yes, sir.
So notice it started at negative 3. That's the value that we have for one of the intervals, and that's going this way. So that's going to negative infinity, right?
Yes, sir.
This piece here, notice that start. Let me hit that. That's negative 1 for my x.
Yes.
See that? And notice it's going to 7. So negative 1 through 7, going through this point. So we stop there. So that's above the x-axis. And also, this piece also right here is above the x-axis. So this piece right here, notice that's 9 above. So if you check back what we just did a while ago, real quick, notice that was our interval, right?
Yes, sir.
Okay, so that's it for that problem. Any question with that?
No, sir, not at all.
All right, do you need to copy that?
I was writing it down the whole time, so we can.
Okay, so pretty good. All right, good. All right, so let me close that out. And let's go now to the other problem. So that's that one. All right, let's look at number 2 now. So for number 2, let me do a quick snippet of that. For number 2, we have the interval given the situation here. They have x squared. They want you to write it in interval form, right?
Yes, sir.
And we have x squared not equal to 9. This is suggesting that, and again, it's pretty easy to kind of illustrate that. We need to figure out what value that do we square will give us 9.
Yes, sir. And that's 3.
That's 3 or what?
Negative 3.
Good. So negative 3 and positive 3. Notice now they say that this right here is out. So let me use open dot. So this is out and this is out, right?
Yes, sir.
So we know what this graph looks like. This graph looks like that. So if negative 3 is out, so that's negative 3 and positive 3, we know that there's going to be a hole there and there's going to be a hole there, right?
Yes, sir.
So they said for each condition listed, express an interval notation for the set of numbers that satisfy this for the solution, that being the case. So every other value except those 2 values would satisfy that equation, right?
Yes, sir.
So my interval then would be negative infinity because I need from over here to parentheses. Notice because negative 3 is not included, that's going to be negative 3, right?
Yes, sir.
Or this piece going to be inside here. Notice now that's again that's going to be negative 3, 3. Notice again this is not included. The endpoints are not included. And then I'm going to have that third piece, which is going to be 3 positive infinity. Make sense?
Let me see. So, okay, now it makes sense. I'm sorry.
Yeah. So any value, let's play around. If you pick a value inside here, let's pick 4, right?
Yes, sir.
4 squared is equal to 16. That is not equal to 9, right?
Yes, sir.
All right. Let's pick a value inside here. If you pick 0, if 0 squared obviously is 0, which is not equal to 9, right?
Yes, sir.
So you get the gist?
I got it.
Okay, so that's pretty much it for that. All right, do you need to copy that or I can keep it going?
You can keep it going.
Okay then, so let's close that out. So that's it for that one. All right, now let's look at these two real quick. And for these two, you have a ton load of ways to do these problems, but I want to teach you an alternative way that can be very fast, depending on the problem. You can work significantly faster this way. So this one is 1b. Let me see my notes. Okay, so for 1b, the easiest way to do this is to recognize that if you have x squared minus 4 greater than or equal to 0, we want where the graph is satisfying, where it's greater than or equal to 0. If I put this to the left, right?
Yes, sir.
Now for this graph, x squared minus 4 going to look something like this. So this is minus 4. That's going to look something like this, right?
Yes, sir.
All right. Now if that looks something like this, we want where it's greater than 0. When it's greater than 0, we want where it's above the the x-axis, right?
Yes, sir.
So above the x-axis is going to be this portion right here. Do you follow?
Yes, sir.
If that is that portion right there, and you know this graph, you know that from here, when I solve this, if I solve this, I'm going to get two values, x equal to 2 and x equal to negative 2, right?
Yes, sir.
This 0 right here going to be negative 2. This is going to be positive 2. So my interval for my solution then going to be negative infinity to 2. Notice the square bracket at 2 because it's greater than or equal to, right?
Yes, sir.
All right. Parentheses right there. It's going to be square bracket at positive 2 go into positive infinity.
Yes, sir.
Make sense?
Yes, sir.
All right. Next piece now. So let's look at C. So for C now, it's still quadratic. Agree?
Yes, sir.
If I solve this, this would be x equal to 2 and x equal to negative 3.
All right.
You follow? So if I turn it into an equation, if I have x minus 2, let me be clear, x plus 3, I just want the zeros, equal to that, these would be the solutions.
Yes, sir.
Good. Now again, it's a minimum graph because the value of a is 1, right?
Yes, sir.
So the graph going to look something like this. So we're going to be at negative 3, we're going to be at 2. So with this being the case, we're going like that. Now again, we need it where it's less than or equal to 0. That is below the x-axis. So it's going to be inside here, right?
Yes, sir.
All right. And again, it's less than or equal to, so the endpoints are included. So my interval then going to be square bracket at negative 3, square bracket at 2.
Got you.
Get that?
Yes, sir.
All right. So that's the situation for that. Now, most of what your teacher is asking is for interval notation, but I want you to be comfortable with set builder notation as well, because very often they write the problem like this. So I want you to be familiar with this notation. This is x, such that x is between 2 and negative 3. Have you ever seen this notation?
I've seen the portion that's like, well, no, I'm just gonna say no, I haven't seen it. You can go ahead.
Okay, so just be comfortable with that. Most of the problems, though, just for I want you to write it like that, okay?
Yes, sir.
All right. Do you need time for this, or we can keep it moving?
We can keep it moving.
All right, then. So that's it for that. So let's now go to this one. All right. Now for this one, we are solving an absolute value equation. Let me see if you can tell me the first step real quick. So we have,
You want to separate
yeah, how?
the equation into 2x plus 3 greater than or equal to 9.
Greater than or equal to 9, yes.
And then 2x plus 3 less than or equal to negative 9.
Excellent. Less than or equal to negative 9. So solving, we subtract 3. So this is going to be 2x greater than or equal to negative 3. 3 from 9 going to be what? 6?
Yes, sir.
Divided by 2, we're going to get x greater than or equal to 3, right?
Yes, sir.
All right. For the next piece now, we have 3. We're going to have 2x. We're subtracting 3. If we subtract 3, what we're going to get?
Negative 12.
Negative 12. So this is going to be less than or equal to negative 12. Divided both sides by 2. What do I get?
Negative 6.
Negative 6. So x is going to be less than or equal to negative 6. Now, once you do that now, you just simply put this on the number line starting. This is negative 6. Solid. It's going right here, right?
Yes, sir.
Going this way. And this one is 3 going that way. So my interval notation is going to be negative infinity to square bracket at negative 6 or square bracket at 3 going to positive infinity, right?
Yes, sir.
All right. So that's it for that one. Any question with that?
No, sir.
Okay. So that's it for that. That's that. All right. So let's keep it moving. All right. So the next problem that you have is very similar. But again, it is beautiful how they did this. But notice here, I thought they were going to kind of follow up with the problem. Notice it's different. It's not 5 right here.
Yes, sir.
Okay, so it's slightly different. All right, so let's do this real quick. And if we do this, with this being the case, we have 2x minus 7. That's going to be less than or equal to 5, less than or equal to negative 5, right?
Yes, sir.
Add 7 to all 3 pieces. Add 7 to all 3 pieces. We get 2x less than or equal to, that's 12, less than or equal to 7 plus that, going to be 2, right?
Yes, sir.
Okay. Divide everything by 2. Divide everything by 2. We're going to get 1 less than or equal to x, less than or equal to 6. So my answer then going to be square bracket 1 through 6, right?
Yes, sir.
All right. So that's it for that. All right. Any question with that one?
No, sir. And I wrote everything down so we can keep it moving.
Okay. Let's keep it moving. All right. So this one now, let's see if we can look at this real quick. So we want to imply a domain from this. Again, for this problem, it must be greater than or equal to 0, right?
Yes, sir.
So we need the absolute value of 2x minus 7 minus 3 greater than or equal to 0. Now add 3 to both sides. We're going to get 2x minus 7 greater than or equal to 3, right?
Yes, sir.
Add 7. Add 7. We're going to get 2x greater than or equal to what?
10.
10. All right. So that's going to be 10. X then going to be greater than or equal to what?
5.
5. Good. Now that's just one piece. What's the next piece?
You have to do 2x minus 7 less than or equal to negative 3.
Okay. So 2x minus 7 less than or equal to negative 3. What do I do next?
Add 7 to both sides.
So you add 7, add 7. We're going to get 2x less than or equal to 7 plus that. That's going to be 4, right?
Yes, sir.
So divide by 2, divide by 2. We're going to get x less than or equal to 2, right?
Yes, sir.
Okay. So again, I always suggest that you do this. Put this on the number line just to see what it looks like, right?
Yes, sir.
So this is a 2, solid out of 2 going this way. I'm going to be at 5 going this way. So this interval right here going to be negative infinity, square bracket at 2. This is going to be square bracket. Yeah, square bracket at 5, right? Going to positive infinity, right?
Yes, sir.
All right, so that's my interval. Make sure you put your or between them, right?
Yes, sir.
All right, so that's it for that one. Any question with this?
No, sir.
All right. All right, so this one now. So number 4 now, you're required to factor number 4. Let me just see if I made any notes for number 4. Okay, that one is pretty straightforward. All right, so let's see. For number 4, let's do a little quick snippet of that. I'm required to factor. So if we're required to factor for number 4, the easiest thing right here is to recognize that you can factor by grouping, right?
Yes, sir.
So if I take x squared out here, this is going to be x minus 1 minus x minus 1, right?
Yes, sir.
All right. Now, if I factor out x minus 1, I'm going to have x minus 1. Let me just square bracket there. X squared minus 1. Tell me if you follow right there.
I do, because what you did was you took since factor by grouping, x minus 1 becomes a factor, and then you take the invisible negative. You take the invisible 1, which is attached to the negative, and bring that and attach it to the x squared and make that as your own factor as well.
Very, very good. So we have x minus 1, x plus 1, x minus 1, right?
Yes, sir.
All right. So that's that. Any question with that?
No, sir.
All right. So that's that. Let's close that out.
Oh, wait, no, I'm sorry. Well, you can still answer it. Was that, what was it? X squared minus 1, was that in brackets or was that in parentheses?
All right, so let me just write it. Now, straight up, it doesn't really matter. All of them is parentheses. I just use that to kind of separate what I was working with, right?
Yeah.
So the answer was supposed to be x plus 1, x minus 1, x, hold on. We have x minus 1. I'm just trying to remember what the answer was.
X plus 1, x minus 1, x plus 1.
It was x minus 1 twice, right?
Yeah.
Yeah. So it was x minus 1, x minus 1. Yeah. So we recognize if we factor completely. Again, just remember that this is x minus 1 all squared as well, right?
Yes, sir.
Yeah. So that's that for that. That's pretty good?
Yes, sir.
All right. So let's keep it going. All right. So number 1 now, what is the degree of the polynomial? The degree is just the highest exponent, right?
Yes, sir.
So that's 3 times 3. That's 9, and 2 times 9, that's 18, right?
Yes, sir.
So that's finished.
All right.
Any question with that one?
No, sir. You just multiply all the exponent, or add. No, I'm sorry. Multiply the exponent that's attached to x cubed minus 1, and then
so let's be careful right here. Let me just write this right here. So if you this right here, normally, let me just do a quick snippet. So right. Okay. So normally this right here, if you expand something a to the m, and this is normally x to the mn, right?
Yes, sir.
So that's why I multiply this by this, right?
Yes, sir.
All right. Now with that being the case right here, we're gonna have x to 9. That's that, right?
Yes, sir.
So 3 times 3 is 9. And then we're going to multiply that by x squared. Now, I was going too fast. We're not multiplying, we're adding, right?
Yes, sir.
So that's x to 11.
Yes, sir.
Okay. So because you're going to be multiplying x squared times whatever this result is, because this is being cubed. So if you cube that, you multiply that by 3, that's going to be 9. Right here, this is 2. If you multiply x to the 9 by x to the 2, that's simply going to be the sum of the exponents. So that's going to be 11. Moving a little bit too quick.
Yes, sir.
All right. So that's good?
Yes, sir.
All right. All right. So that's it for that. So this one here, when P is written in the standard form, what is A8? What is A0? Right?
Yes, sir.
All right. So what is A8 and what is A0? So this problem going to take us a little bit of time. So let's do the others. And then if we have enough time, we'll come back to this, right?
All right.
All right. A8 can be this. Yeah, we discuss it after because I want to just go through the easier ones first, right?
Yes, sir.
All right. So for number 7, to get credit for this problem, you must provide a complete solution, not just an answer for how many solutions, right?
Yes, sir.
Yeah, so this one's a little bit shorter, so let's look at it. So again, using the same principle of the absolute value, we're going to have x squared minus 8 equal to 1. And we're going to have x squared minus 8 equal to negative 1, right?
Yes, sir.
All right. So with that being the case, we're going to have x squared equal to, add this to both sides, we're going to get 9, right?
Yes, sir.
Okay. Now, if you add that to both sides, you're going to have to do the same thing right here. So this is going to be x equal to, if we add that to both sides, we're going to get what? 7, right?
Yes, sir.
Okay. So if we get 7 right here, we're going to have x equal to plus or minus 3. That's good.
Yes, sir.
And x equal to plus or minus the square root of 7, right? So this is 2 answers. And this is 2 answers, right?
Yes, sir.
So that's going to be E, right?
Yes, sir.
All right. And we can play around. If you actually play around with this, you can actually verify that this is true, because if you square 3 right here, or negative 3, you're going to get 9. 8 from 9 going to give, going to definitely be 1, right?
Yes, sir.
If you square the square root of 7, you realize you're just going to get 7. You're going to have 7 minus 8. That's going to give you a negative 1. Absolute value of negative 1 is positive 1, right?
Yes, sir.
All right. So let's do that. All right. So let's look at this one now. So for this one, find all the x-intercepts for the following function, right?
Yes, sir.
All right. Now, this look like a beast, but it's not pretty. This one is a little bit simpler than the one above. So let's see if we can look at it carefully now. So with this being the case, we recognize a pattern right here. Notice that this here is the same as this, right?
Yes, sir.
Very similar. So what I could do then, I could factor out the lowest piece, the lowest 2x squared minus 1, right?
Yes.
So that's 2x squared minus 1. I also could factor out together a 3x plus 1, right?
Yes, sir.
All right. So if I'm able to do that now, let me just use a square bracket just to kind of differentiate between the 2 different pieces. This into this going to give me 2x squared minus 1, right?
Yes, sir.
Because this here going to drop this one out. So I'm going to only have 2x squared minus 1, right?
Yes, sir.
This into this going to drop out. So I'm going to have negative, this piece going to remain. So that's going to be negative 3x minus 1, right?
Yes, sir.
All right. And we have another, close the square bracket there. So here we're going to have 2x squared minus 1, 3x plus 1. Then we're going to have 2x. Oh, sorry, my battery is running low. Give me 1 second.
Yes, sir.
All right, there we go. So with this now, we're going to have, remind me later. All right, so we're going to have 2x squared. Notice here now, we have minus 1 right there. So we're going to have minus 3x, good, minus 2, right?
Yes, sir.
All right. Now, if I put a little factor, I don't know if this is how they taught you to factor. You multiply this by that, you get negative 4. A by C, you get negative 4. You remember that?
Yes, sir.
Negative 3. 2 numbers you multiply to get negative 4 and add to get negative 3. That's going to be negative 4 and 1, right?
Yes, sir.
All right. So this piece here going to work out to be 2x squared minus 4x plus x minus 2. If I factor right here, this is going to be 2x, x minus 2 into this is going to be 2, right?
Yes, sir.
We're going to have x minus 2 right here, plus 1 right here, because if I multiply this by that, I get back that. I'm going to get 2x plus 1, and I'm going to get x minus 2. That's good?
Yes, sir.
All right, so now we need to solve all of these now to figure out what they are. So all of these now, we need the x-intercept. The x-intercept is the same thing as the zeros, right?
Yes, sir.
All right. So we're going to have then 2x squared minus 1 equal to 0. We're going to have 2x squared equal to 1. Then we divide by both sides. So we're going to get x squared equal to 1 divided by 2. So we're going to have x equal to plus or minus 1 divided by the square root of 2, right?
Yes, sir.
All right, x here going to be equal to negative a third. That's one good, right?
Yes, sir.
Right here, x going to be equal to, if we bring this over, that's going to be negative 1 divided by 2, so that's negative a half, right?
Yes, sir.
And this piece here, x going to be equal to 2. That's good?
Yes, sir.
All right. Any question with that one?
So what now?
Any question with that one?
No, sir. Could you give me a minute to write this one down?
Oh, sorry. I was just, sorry. I almost cleared it out. Yeah. I thought you said to move ahead.
Oh, yeah, no.
All right, so let me just pause this thing for a second.
Okay.
Okay.